Hello, everyone. This is our second session, which we are gonna investigate numerical arrays, slicing, and few simple functions that I've been meaning to present. First thing first, we are gonna work on NumPy library again using Python. It enables us to do numerical calculations using Python. So first, we're gonna import it. And then we're going to go through simple definition, transpose, and then we will go deeply into slicing. And once slicing is done, I'll present few NumPy functions that are handy. And then we're going to have a stress testing of a material as an example. So let's dive into it. An array is the way that we are going to form our matrix that we do need for manipulation and for calculations, engineering calculations. The way we do that is using numpy.array. And as you can see, I use NP as an abbreviation for NumPy. So if we have four type of arrays, 0 dimension, 1 dimension, 2 dimension, and 3D. 0 dimension usually called single value, and it's an array. You can see it's just MP array parentheses. There is no brackets used here. Then we will have 1 dimension, which will have one set of brackets. And first variable, second variable, and the syntax is super important here. So make sure that you follow the syntax, parentheses, brackets, and then commas to separate the values. Then we will have a 2D array, which we call it matrix in linear algebra. And here it's called matrix. Vectors are matrices as well. But we have different descriptions on NumPy for them, just to be more specific. That's it. A 2D array has first row and second row, and each row can has its own values inside them. So the distinguish that I need to make here is the note that I need to make here is parentheses and 2 tiers of square brackets. And as you might have guessed, 3D has 3 tiers of square brackets. And same, we use commas to separate matrices or rows or variables. So this is the first row of first matrix, second row of first matrix, and it goes on like that. Just to visually present them, 0 dimension is a 0 dimension single value, so that explains itself. A 1D is a vector, and it's going to have different values inside the brackets, and then we stack them on top of each other, and we will have a 2D matrix, which like this is very simple and just for visual purposes. 2D is a stack of 1Ds, and a 3D is a stack of 2Ds. So one is a line in a book, second one, 2D dimension is a page in a book, and a 3D is a book itself, a collection of 2Ds. That's a simplified explanation of it. And we do need two functions, two methods, I would say, in order to check our arrays and make sure that the dimensions and everything are correct for matrix manipulations and operations that we will see in the future. And those are just linear algebra specific that are required to be able to do manipulations on a matrix. That's why we need to know the shape of a matrix that will give us depth, row, and column. If it's 1D, we just have a column indices and one row. And then we have, if it's 2D, we have row and column, and if it's 3D, we will have depth as well. So that is a.shape, or shape parentheses a will give us that. And then we have dimension. We might need to check dimension of a matrix or an array as more accurate. So let's use this syntax and define array B. Array B, as you can see, starts with two sets of brackets after parentheses, so it's a 2D, and it has three values separated by comma. So it has three columns, and as you can see, 1, 2, 3, 4. So it's a 4 by 3, which 4 rows, 3 matrices, 3 columns in this matrix. And RB stands for row, and C stands for column. B.shape will give us the values for that. And here, using dot format, we can print them along with print. So as we expected, the number of elements are just row times columns. 3 times 4 is 12. We can simply define a matrix using NumPy array in Python. Now we know that. Let's transpose a matrix. And a transpose of matrix is where rows and columns are changed. If we have M with M00, M01, M10 elements, if we transpose this, M01 will go to M10 instead, and M10 will go to the M01 position. So if we have a N by M matrix, the transpose will be M by N. So here we have 3 by 2, the transpose is 2 by 3. We can use B.transpose parentheses or transpose parentheses B inside. Here again, we had defined B transpose is B.transpose parentheses, and we can check the row and columns of BT, and it should be 3 by 4 instead of 4 by 3 as B was. Now let's just put them together and see them as a one code block. This is B, this is BT, and the shapes 4 by 3 versus 3 by 4. So this is working. Now we know how to define a matrix. We know how to transpose it. Let's see how we can access an element. Let's say these are the results of an experiment, or these are different data points that we need to access, and a specific one or a group of a specified one that have a relationship in terms of position and indices they have. Like it could be the degree of a city. Each row can be the temperature degree of a city. So we do need to access information inside our arrays, if it's a vector, if it's matrices, or if it's a tensor, which is 3D. Before diving into that, an introduction to slicing is knowing the access. I do like to explain this with the flow of information. In a vector, you only have one flow of information. Information can follow in only one direction for the flow of information. In 2D, you have row and column, so you have two directions provided for information to flow and provide insight and capture behaviors, which we will manipulate and get insight from. So you have axis 0 direction, which is a direction of rows, and you have axis 1, which is the direction of columns. And then in 3D, you have three different directions. Depth is the 0 axis, and then which is one direction, and row and columns like a matrix. So having this in mind, there are some functions that accept access. You can specify which axis you want the manipulation to be done, and then by default it goes with axis 0. So if you have 1D, it's an element base. If you have 2D, it's a row base, and it's if it's 3D, it's going to do the manipulation on depth base. Now let's go to 1D slicing, and 1D here is the dimension. So we are going with 1D arrays. which is an element. So this is the basic, and it is the fundamental slicing. Once we know this, then the 2D is just 2 1D slicing, and the 3D is 3 1D slicing in a stupid way, if I just want, for lack of better words. So if we put our focus on 1D, we will be able to easily slice 2D and 3D arrays. This table has all the styles available with their description, a brief description. They are kind of the different versions of the start, stop, and step. So I would say this row here of the table is the essence of the entire slicing concept. And once we know this, we will know everything. But let's start and build up toward this, and then we will see some not conventional way of slicing. Yep. So as an example, I'm not using a number. I'm using strings, and I'll go with my name, Puria. And you can see just ignore the light blue ones and focus on the dark, light colored ones, and focus on the dark blue and dark green. These are the indices associated with each position, and Python starts from 0 positioning. As you might know, like programs like MATLAB, which is popular among engineers for numerical, starts with 1 for positioning. But here in using Python, we start with 0. So P, which is the first letter used in my name, is in 0 position. And it goes on. We have O as 1, O as 2, R3, I4, and Y5, finally A6. So if I make the array 1D array of my name, you can see it has 7 elements, and length will give us the elements, number of elements in 1D. Now let's say I want to access Y. Y is at 5th position of the array A. So to access the 5th index, which is 6th position of my name, of this array, we need to use brackets after the array name, so A, and then brackets, and then we just simply write the position that we are interested in. And A5 should give us Y, which is correct. Then we might want to access a group of numbers that are next to each other. So we use a start, stop, and the only thing matters here in this style. When you say stop, from start and then to stop, stop is not included. So start to stop and stop is not included. It's excluded. So that's the only thing matters here. So if you are looking for indices from 0 to 3, which is P to R, R is not going to be printed. It is going to be excluded. It's not going to be even not just printed. I mean, it's not going to become part of that list that you're making. So here, if I go with this style, I print A every time at each style. So you can see the difference. So 0 to 3, 0, 1, 2, 3, 3 is excluded. So start, stop is always stop -1, stop excluded. We can use a negative indexing here. And negative indexing, remember, it starts with the minimum number, -7. It doesn't start with -1. P was 0, and it is -end, which is 7 elements here, to -1, and it increases. So we can go from -4 -4 being, I think R again, sorry. -4, we're going to, from -4 to -2, which is Y. And again, -2 is gonna be excluded. I'm not sure if I have, okay, here. I could have gained the same result. And 5 is -2. -2 would have given me Y as well. Now 0 to 3, and now I'm going from -4 to -2. Let's print this, and -2 is going to be excluded. So this one is 0, 1, 2 to 7. So -7, -6, -3, -4. Actually, we don't need this. Sorry about that. Here you can see, and -1, -2, -3, -4. So -4 is included, -3 is included, -2 is excluded. We can go, I better put this here. And here we go. So we can go from start and do not specify stop. And it is, if we don't specify stop, it means to the n plus 1. So n is included. So if we just use dots instead of making any stop, it will go from start to the end and included. I better say n plus 1 here. So it does make sense that end is included. Let's make it like this. So it goes to n plus 1. Since end is in a stop, n plus 1 is in a stop, and the last element is included. As you can see here, it starts from 2, which is 0, 1, 2, the second O, and it goes all the way to the n plus 1, which makes end included. Now, if we just specify stop, it starts from the 0 element, which is the first element of the array, and it goes stop -1 to element including 4 in this example. Let's carry this. Element 5 goes to the I. An element in index 5 is y is not included. 1, 2, 3, 4, 5, correct. 5, y is not included. Scared me a bit there. And then finally, if we use if we don't specify start or stop, it's just gonna go through the entire thing. It's a dumb way of making a copy of a matrix, for example, or if of any array. So this way we can make a copy of all the elements as a list. And if it's 2D, it's not going to be 2D. It makes a 1D array. Identical copy of an array. We have a double. There are other ways of making a copy, which we will see. And let's go from, okay, now we will see the entire image. All these specific examples are made based on start, stop, step, and stop is excluded. So you can, instead of going all the numbers that are next to each other, you can specify a step size, like every other element. So from 0 to 7, 7 is excluded, and we are going to go every other alphabet. So P, second O, I, and A, which works. And then we will have like from 1 to 5 every other element. 0, 1, 2, 3, 4, 5. So O and R works. It's the first O and the R. And you can see this is in this is 3, 4, 5, and Y is not included, and we pass the stop, and the step will not work. And again here, you can see that we have 0, and then 1 is not there, second is there, third is not there, fourth is there, and so on. 3 different examples. Now, this is start, stop, step, which is the most important, I would say, style. Everything comes like that. Oh, I do have this. Then you have an array that you don't know the size, or it's a result of a an operation that you don't know how big how big it would be. You can just and you're interested in the last element. Let's say it's a control situation, and you're just interested in the last element. You can use a-1, which will give you access to the last element. And here, I don't need to know how big this array is. I just go with a-1. Then we will be able to, as I said, it is start, and we didn't specify any end. So it's going to go from -2 to n+1. And here, n+1 is, let me run, n+1 is this 0, I would say, because a is the -1, correct? So it goes from -2 to 0, stop +1. And let's correct this one as well. And +1. So it'll gonna print everything after -2. Or we can like leave start blank, and I have -2 here, -3 there. Let's go with 2. So here we don't have any start specified, so it's gonna start from the beginning, and it will go till -2, and -2 is excluded. So -7, -6, -5, -4, -3, and -2 is excluded. So it'll gonna print this one. And then we have reverse, start, stop are not specified, and only step is specified. So we are in the negative indexing domain. It's gonna start from negative indexing, and it is gonna make everything reverse, correct? Because it's gonna start with -1, and then -2, -3, -4, -5, -6, and -7. So resulting in a reverse array. I think I went a bit fast. So we have a minus stepping size, and we know first element is -7. If we have a minus minus a step size, we cannot start from the first element in the array. In negative indexing, the element associated with the index associated with the first element is minus, in this example, 7, the last element, minus last element, which is -7. So if we go with negative indexing, the next one should be -8. -8 doesn't exist. So it starts from -1 and -1, then the next one is going to be -2, which is the second last element. And that's why we use this to make a reverse of an array. And then again, start, stop, step. If we follow that, we don't need to memorize what each style does. We can just go ahead and interpret and understand the command inside the square brackets. So we are gonna start from 1, and we don't have any end, and we are gonna go negative indexing. So we have 1, so we start from here, and we will decrease 1 from it, so it's gonna go to 0. So reversed first 2 elements is 1. If it was reversed 3 first elements, so we would have start from third element, which was 2. The index associated is 2, and it would have given us the same result. And as you can see, there's a reversed first 4 element, and it gives us this. The other style is we specify end, and we are going with negative stepping. So we don't have a start, we just have an end. The end is -3, which is the second O, I think. Sorry, -3 is I. I did make a mistake. So the end is -3, which is I, negative indexing, and we don't have any start for it. Negative indexing, we are going to start from A. So -1, -2, and end is not included. So this is how we make last 2 elements reverse. First 3 reversed, first 4 elements reversed, last 2 elements, first 4, last 2. And that's how we make these. So like they are all different versions of start, stop, step with just the elements of being mindful of negative indexing and where it's gonna land us. The other one, we specify start, we don't have any end, and we are going with negative. So we will start at -3, we don't have any end, and our step is gonna be -1. So we can't go toward A because from -3 toward A is a plus. So if we are starting from -3, so -3, -4, till -7, so we exclude last 2 and we get reversed. So this is everything that we need to slice. And as you could see, once we got familiar with those special cases, then it is way easier to understand reverse, last 2 reverse, last 2 not reverse, first 3 excluded, like those different ways of referring to certain elements is just a different way of saying start, stop, and step. And the only difference is negative indexing compared to MATLAB. I assume most of us work thus. Just being mindful of negative indexing will make life way easier. Let's go to do 2D now. And 2D, as I said, it has a row, it has a column. So you need to do a slicing for a row. And once you get the rows you were interested in, you do a slicing on columns that you're interested in those rows. So rows comes first and then columns. Same table, I just put it here as a reminder. Let's define B again. and this is the way B is presented, correct? Now let's say I'm just interested in one element. That element is at indices for row, which we need to find first, is at first row. I would say index 1, which is second row, and column 1, which is second column. So B11 will give us number 20. Let's say we need 20, 30, 200, 300, 2000, 300. So we just don't need 0 elements from each, correct? So if you look at the rows, so from rows, forget about columns. We want from 1 to the end, 1 to the end. Now let's look at the columns. We need from 1 to the end, 1 to the end. Print, it gives us a new array that only has those. And it is a 2D array, 3 by 2. If I go with shape, you can see it's a 3 by 2. Then let's say we need even smaller. So from row, we need 1 and 2 indices, second and third row. So 1 to 3, 3 is excluded, and 1 to end, 1 to end. Column hasn't changed. And this one now is way easier, but let's do negative. So if we do negative, it is -4, -3, -2, -1. So we need from -4 to -1, because -1 is going to be excluded. And then here we need -3 and -2. We don't need -1, so -3 to -1. These are fairly simple examples, and you just need to work a bit. And I didn't provide any examples or any practice for 1D because it is going to be repeated, and it's the same for 2D, and in 2D you get twice the practice. So here are some examples, 2 examples of fairly simple ones that you can try. Let's go to 3D. And 3D is just 1D. So you go with different arrays. You go just with different arrays. And if it's the first element at depth 0, sorry, you just go 0 and everything. So let's see this one. Let's define a 3D. See a 3D tensor, or let's see a tensor or 3D matrix. So here we have 3 layers, correct? 1, 2, 3. And we have 4 by 3. So 4 rows and 3 columns at each layer, correct? Numerical, alphabet, and Romanian. Let's say I'm interested in second layer, second row, second column. What is the value there? Let's say this is just one element in a 3D. Second, 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 which is index 1, 1, 1. And I get alphabet E. Let's say this is the age first. Doesn't work. I lack something here. But this can be, this can represent an abbreviation information of someone. Like it is abbreviated, and it can each column on depth, each element at the same row and column presents a different information about that person, that city, or anything. But it's a way of sorting information. So I now have access to E as a part of that information. Let's say I want to complete a person. These are different information about a person. So, and all the information associated with that person is at 2, 1 at different layers. So I want all the layers and 2, 1 indices. I get 8H and number 8 in Romanian, whatever it means. Next one. So here we first specify the layer / layers, and then we go with row and column that we are interested in. Let's say I just need the last three columns, last three elements in the last row. So it means every column, last row of the last layer. So last layer, fun fact, if you don't specify in 3D, if you don't specify this, should have shown this on 2D as well. Okay, let's remind B. Go here. Let's in B and print B1. Oh, what did I write? Print. So B1 is 10, 20, 30. So it is gonna, the first axis that I left blank, I didn't provide any information. It means everything, correct? So it is giving me the entire first row, all the columns. So first axis is what this one is a representation of the row that I'm interested, and then it is gonna give me all the columns. If I went B0, 1, 2, 3. So this is the first axis in a matrix. Now let's go 3D. 3D, I'm just specifying the depth, which is second one, and the row that I'm interested. It's gonna give me everything of the last piece of information that I didn't provide a number for it. So it's gonna be all the columns and they are equivalent. And if I needed first layer, so C0, all the rows, so I just go with the dots and then first column. Again, layer, rows, columns. And because I want everything for rows and columns, I just specify the first axis. I just specify the layer I'm interested in, and they are equivalent. Now let's say we want to go with a portion at every layer. So every layer from 1 to end, from 1 to end. I am sure they are fairly easy. Once you practice a bit, you'll understand it and you'll never forget it. These are some examples based on what I have shown. Sometimes a bit challenging, but I'm confident that you will be able to finalize it. Let's jump into NumPy functions, because now we know how to define an array. We know different type of arrays. Then we know slicing, and we can do slicing on 1D, 2D, and 3D.